All right, so part 9 in the notes, 1.4, is where we begin transformations. Well, first we're going to talk about translations. We have a vertical translation. And your instructions on your homework problem would be something like graph g of x equals the absolute value of x and then minus 4 on the outside with its parent function. And we're going to call the parent function f of x. All right, so I need to graph the parent and then graph the transformed function. So I'm going to set up my xy plane. And then I'm going to graph my parent function in red since that's what I've been doing. Absolute value, parent function, starts at 0, 0, and it's the v. If you don't want to use colors, you can use dashed line, solid line to make it obvious which one is which. And then you should also be labeling. This is f of x because it's my parent function. And then I am going to graph g of x, the transformed function. It's the absolute value x and then shifted down 4 because of the minus 4. So 1, 2, 3, 4. And that would be g of x. And label it. So there is a lot of graphing. Your homework is graphing this assignment. So you will need to graph. All right, next one. G is reflection. We have a reflection, and we're told to graph g of x equals negative 1 over, and then in the denominator, x plus 4, with its parent. So with parent f of x. So same thing, I need to set up my xy coordinate. And then I'm going to graph the parent function, f of x. So this is a reciprocal, 1 over x. So that's what I'm going to graph. I know I have the asymptote at the y-axis. So I have a graph in quadrant 1 and in quadrant 3. The exact values on those are not really important. We're just going to estimate that. It should look something like this. And then I need to reflect it, and I need to shift it to the left 4 spaces. So if I'm going to shift my graph to the left, I'm going to take this vertical asymptote at 0, 0, and I'm going to shift it to the left 4 spaces. So 1, 2, 3, 4. And then what I had in quadrant 1, since I'm reflecting over the x-axis, I'm going to reflect it down here. Oh, that was almost blue. It's kind of ugly, but it's okay. And then what I had in quadrant 3, I'm going to reflect up here. And then I'll call this g of x. Oh, I didn't label f of x. If I didn't have all this labeled and it was all done in black, it would be messy and I wouldn't really be able to tell what's going on. So whether you use colors or you use dashed and solid lines, just make sure everything's labeled and you can tell what's going on. So the next one, dilations. We have 2 dilations. The first one is a vertical compression. G of x equals 1/4 x to the 3rd power. Same instructions. We're going to graph both. I'm going to do these 2 side by side. So parent function x to the 3rd power. Oh, you can't see it anymore. Parent function x to the 3rd power. So cubic function 0, 0, 1, 1. 2 would go up to 8. So it's going to be like that. And then the same going this direction. That's f of x. Parent function. And then g of x is 1/4 of that. So vertical compression, I use the Play-Doh analogy on that one. So if this red graph was Play-Doh and I wanted to compress it vertically, it'd squish it from top to bottom like that, and it would squish, like Play-Doh would squish out from the sides. So I know I'm going to take this and squish it together. It's going to make a short fat graph. So instead of 1, 1, I'm going to go out 4 and up 1. So my 1, 1 becomes 4, 1. And 1, 2, 3, 4. 1. And that is g of x. So along with vertical compression, we also have vertical stretch. This one is going to be g of x equals negative absolute value, and inside the absolute value bars, 4x. Negative absolute value inside 4x. All right, so parent function, f of x, is the absolute value x. It's my f of x. And then I'm going to reflect it, and I have 4 times x, so I'm going to stretch it by 4. So again, if I'm talking about the Play-Doh, if I take this red one and I stretch it, it's going to get tall and skinny. but I'm also flipping it. So here. So then at 1, it's going to be 1, 2, 3, 4. And negative 1 is also coming down to 4. So it's going to be a skinny graph. And that is g of x. All right, so I have one more thing for today, and that is part 10. And a lot of you have asked about this already, and now I'm going to show you how you would graph a piecewise function. Piecewise function. Kind of messed that up, but it's fine. Piecewise function. Graph f of x equals, and since it's piecewise, we have this big set notation bracket, and there's going to be 3 pieces to it. So the first part, 3x squared, 3 times x squared, and that is when x is less than negative 1. And then the second part is just the constant negative 1, and that is when negative 1 is less than or equal to x is less than 4. So that's for that interval of the domain. And then for everything else greater than 4, we have parentheses x minus 5 to the 3rd power plus 2. And that is when x is greater than or equal to 4. So there's the piecewise function. We're going to graph that. And you just take out one piece at a time to graph it. So first I'm going to take, on the left, I'm going to start left to right. So the furthest most left part is this one. So when x is less than negative 1, I'm using the graph 3 times x squared. So it's quadratic that's been stretched by 3. The easiest way to do this would probably be take a pencil, and if I just graph 3 times x squared, so it's 0, 0, and then 1 times 3, 1, 2, 3, 1 times 3, and then it goes on from there. So this is a stretched parabola. But I'm only concerned about when x is less than negative 1, and I'm not including negative 1. So if I go to where x is negative 1, and I go to my graph, I have this point, but I'm not including that point, and I only want everything smaller than that. So I'm just using that part of the parabola. And then I can erase the rest of it because it's not part of my graph. So that's probably the easiest way to do most of these whenever they're complicated or transformed. Just graph the whole thing, find the part you need, and then get rid of the rest. So I just graph it lightly. And then the second one is f of x equals negative 1 from negative 1 to 4. For the x values negative 1 to 4. So that's a horizontal line at y is negative 1, and it goes from negative 1, and I'm including negative 1 all the way to 4. 1, 2, 3, 4, but I'm not including 4. And then I graph the last part. For x's greater than or equal to 4, I'm doing a cubic function that is shifted to the right 5 spaces and up 2 spaces. So again, I'm going to lightly do it in a pencil. So from the origin, I'm going to shift it to the right 5. 1, 2, 3, 4, 5. And up 2. 1, 2. So there's my new start. And from there, I'm going to do my cubic. So I know it goes over 1, up 1. And then it gets really steep. And then over 1, down 1. And then it gets really steep. So there's my sketch of my cubic. But I'm only concerned about x's greater than or equal to 4. 1, 2, 3, 4. It's this line. So that dot right there is going to be a solid dot. And then I like to include that start here. And I don't care about the rest of it. Right here. And that goes away. So there I have my piecewise function. So you graph each piece based on the interval the domain is telling you to graph it for. All right, so your homework assignment is on page 52. You're going to do numbers 25, 26, 27, and then 29 through 37, odds only. And this is graphing, so you will need to make sure you're doing nice, neat graphs and doing it properly.